Hey guys, welcome to the fourth episode for the Road to AGI. And today we are going to talk about knowledge representation for AGI. As you know, my name is Amritansh and I'm here with Tamal Acharya. Hey Tamal, how are you?
Hey Amritansh, how are you? I'm good.
Hey, thank you. Okay guys, so I think without any further delay, we should start the discussion today and we want to learn what is knowledge representation and how it can be useful for us. Okay. Now, as you guys know, this is kind of a continuation of our previous videos already. So we will really implore all of you to watch the previous videos to get a better understanding what are we discussing today here. All right. So guys, we kind of talked about knowledge base a little bit in the last video in lifelong machine learning. And here again, we thought to dedicate a full video about this. And there are so many complex problems encountered in AI, and we do require to have knowledge and suitable mechanism for representing and manipulating all that knowledge. Okay, so even when you are trying to solve any problem, let's say you are trying to do long-term reasoning, okay, or like a long-term planning or extremely complex reasoning that you are trying to do, you would be requiring different kind of knowledge base to kind of compare the information and even try to make inference based on that. So AI has fundamentally two objectives, either like your prediction, numerical prediction or classification. And in many cases, like again, if you're playing some kind of game, like you need to understand what is the basics here, what are the laws of physics and everything. Okay. And if you're trying to work in a custom environment, then the same problems will occur. And if we let everything learn from scratch, it might be too much. And again, we will have to create a lot of annotated data. Now, there comes this discussion that if we have to fuse a hybrid model, wouldn't it be nice to have a knowledge representation? And as we can say, knowledge representation in AI describes a representation of knowledge. It is a study of like how beliefs, intention, judgment of an intelligent agent can be expressed suitably for automated reasoning. Okay. And one of the primary purpose of knowledge representation include modeling intelligent behavior for agent or artificial agent. Like as we must have gone through our school time and we have acquired a lot of knowledge and we keep doing so every day while interacting at our work with people around us, within our family members, right? Same thing we want to see in a lifelong learning scenario. Can we imagine the same idea? And can the AI agent also keep learning and kind of keeps adding new ideas, new knowledge, beliefs, all of that into let's call it a knowledge graph. And knowledge graphs are basically like maps. Like I could give you a simple design here if you guys are interested. It could be a simple kind of graph structure, okay, and where let's say things are connected. Let's say Google is somehow connected to internet search, okay, but search is also dependent on the artificial intelligence, right? And so on. I can start making these massive connectivities, okay, and search could also be dependent on like different ideas of computer science. Okay, so on, and one could start to build these kind of massive knowledge graphs. And the good part is like these large companies itself are kind of utilizing this. Okay, so like Google uses knowledge graph, which is used primarily in your web search. Amazon has its own product graphs. Now, of course, these are internal. You will not get access to these things. And the other knowledge graphs which are openly available can be called, which is DBpedia, Wikidata, WordNet, GeoNames, right? So I will really implore everyone to have a look at these to kind of get a sense like what we are talking. And even we will try to explain you why this is important and what could be examples and what language type we might even have to deal with while dealing with knowledge graphs. Okay, all right. And again, if you remember this picture, this is from our lifelong learning video, and where we kind of gave this idea of knowledge-based learner, and we said there needs to be knowledge, especially knowledge base for the retained knowledge. So you might be trying to learn from various tasks and you must be gaining knowledge. And the whole idea is to keep this stored, especially the retained one, which we don't want to retain for long term or for the next task and the subsequent task. That needs to go in knowledge base, but we never discussed like what we need to do exactly do for this purpose. So today we are going to have a look around at that. Okay. Now, let's discuss then what is knowledge base fundamentally. Knowledge base is like a central component of knowledge base agent and represented like it can be collection of sentences. Like sentence is a technical term. Please do not get fooled by like English sentence or something. Okay. These sentences are kind of expressed in a language which we are gonna kind of discuss later in this video. and which is called knowledge representation language. Knowledge base of KBA basically stores facts around the world, about the world, or whatever we keep learning through different tasks that we know, right? And the idea of knowledge base in artificial intelligence aim is basically to capture human expert knowledge to support decision making, problem solving. Through the years, knowledge-based systems have been able to develop to support many organizational processes. And even like many times when we are working with machine learning, we need to keep humans in the loop because see, most of the time machine learning and a lot of techniques around statistical inferences are primarily like behaving based on correlations. Okay, and like there is a lot of discussions around correlation, but as you might know, correlation is not always causation. Okay, so it doesn't mean like if you can just show very high correlation between two columns or two fields, it means one is causing the other, or vice versa. Maybe it is going in one way, maybe it can go from A to B, but it cannot come from B to A. That can happen, right? Height and weight are like highly correlated, but usually increase in height kind of causes increase in weight, right? Vice versa is not true. Just because you start to get fat, it does not mean you will also get taller, right? But see, that is what needs to be explained to machine. Otherwise, we will have to supply millions of examples to just maybe give it some kind of a pattern recognition system to make it work. And that's not always feasible for us. So in simplest term, basically AI provides the mechanism that allows machine learning for or to collect these kind of knowledge. Okay. It allows them to acquire, process, and use knowledge to perform tasks that display intelligent behavior, such as like your perception, learning, knowledge representation, and reasoning, one of the major important unsolved tasks according to me. Planning, especially long-term planning, that's really hard actually. And execution, okay, that how do you execute, and as scenarios will change in the future, then how do we adapt to that? And if some new information comes into being, how do we act on that? And again, understand why we are talking about new information, because this might be very small bit of information. You will not have millions of sources of data that you can say, oh, why can't you run deep learning and adopt based on that? But because we will not have millions of data points by that time. So that might be a little problematic. Okay, and again, the overall idea is very similar. Okay, that fundamentally what we are doing through knowledge basically is based on the knowledge and based on the whatever sense and whatever like sensor information we are getting, the core part of AI is to basically make decisions at the end of the day. And then fundamentally, you can have a physical manifestation, or it could be just an outcome and on which human systems or systems designed by humans would kind of take an action at the end of the day. But it cannot be always justified with millions of data. Like I cannot go ahead and sense 10,000 donuts to tell it is a soft donut or like it is soft in nature, right? Many times if it was to be included in somehow in the database or some kind of knowledge graph, it would be far easier for the AI to learn from there and with least amount of examples, and it can continuously keep on happening, right? So let's say you know about coffee, right? So coffee is served hot, but you also know that there is something called cold coffee. So that can also be a variant, right? So that if I always have to give millions of examples of cold coffee and hot coffee, that might not be optimal for designing a lifelong learning AGI system. Okay. All right. And here is one very good example of knowledge graph. So let's say James here likes Mona Lisa painting. Okay, now Mona Lisa paint was done by Leonardo da Vinci, as you might know. Okay, and it is present in Louvre Museum, which is a museum which is located in Paris. Okay, okay, and even Eiffel Tower is also located in Paris, right? And Paris is basically a place. And thus you can start to see, even if you know few bits about some pieces of information, maybe I know, let's say that James has visited or frequently visits Louvre Museum and he likes Mona Lisa, we can make an assumption or we can make a prediction. James might live near Paris or maybe inside Paris. Maybe this part, okay, maybe this part can be inferred based on the search over there. I'm not saying, of course, you will have to deal with probability here. You will have to think in Monte Carlo simulations as well, but this would be the scenario that one will have to think about. So knowing how to apply that knowledge to problem solving and decision making is intelligence. So yes, we will have this knowledge and then how we apply. This will be the true test of intelligence. AI knowledge management is like a strategic process where organization creates value from intangible assets. And again, like by creating all these massive knowledge graphs, we are able to assemble knowledge and then act on it or take decisions. And this is what I think the modern day AI is lacking as of now. So definitely this is something that a lot of research is being focused on then, and there are research groups all across the world who are looking into this direction and try to solve the problem. So let's go ahead and see what more we can learn here. So this is like a very interesting picture, and so Tamal, would you like to kind of explain about this picture?
Yes. So thanks, Amritans.
Yeah.
So here, as you can see, there are three pictures. So the first picture is two ghosts meeting on a bridge. Second picture, they are fighting. Third picture, both of them fell on the river. Now, we know how to connect the dots. We know how to connect the pictures. How we know what can be the sequence of events from these pictures. Now, just by observing these pictures, we know the sequence of events that has taken place. Now, this is kind of an idea of a knowledge graph. Like we have some pictures and we know how to connect them. And the connection is the logical sense. I mean, it's like the logically connected, or the series, or the sequence it has taken place. So this is this is the intuition behind the knowledge representation. Like we have some pictures and then we know how to connect them. So this is all the basic intuitions about the knowledge representation. So as we move on, we'll see more in depth of what is there in knowledge representation.
Sure.
So moving on. Yeah. So as you see, the knowledge-based agent as one introduced by Amritans. So what that agent should be able to do or must be able to do, it should represent states and actions. Yes. It should incorporate new percepts as we do. We keep on adding to our knowledge. It should have an internal, it should update the internal representation of the as well as deduce the internal representation. So it's like you keep on updating with new knowledge, and then you deduce something from them. It's like inferring. And then you deduce appropriate actions. So we acquire knowledge to do something, to represent something or something. Some action needs to be taken with those. Otherwise, it is just a one-way track, like we are just keep on accumulating. So what to do with those knowledge? Either you pass it on to someone, you take some action, you do something. So this is the deduction of the appropriate action based on the knowledge you acquired. So all these things are knowledge-based agents should be able to do.
Yeah, I agree.
So moving on. Yes, so Amritan introduced few knowledge graphs. This is another example. Like we all know Star Wars and Star Trek, those are the two famous franchises. And Obi-Wan Kenobi is from Star Wars, Spock is from Star Trek. Spock was played by Leonard Nimoy, and Obi-Wan Kenobi by Alec Guinness. So both Star Wars and Star Trek are science fiction genre. Spock and Obi-Wan Kenobi are fictional characters in their respective franchises. So this is how it is connected. By looking at the pictures, we know how to connect the two characters and the two franchises. So this is all about an example of a knowledge graph. So in real world also, as you see Facebook, the relationship like friends of friends, relatives, mutual friends. So all these things. So these are all relationships. So if you plot a knowledge graph around, take any one person and you plot, it will come like this, a similar kind of picture you will get. So moving on. Yes. Now, before knowing in depth about knowledge-based agent, we should know what are the different types of knowledge. Now, first is, there are 5 different types of knowledge. First is declarative knowledge. It is all about concepts, facts, objects expressed as expressed. Then you have structural knowledge. It's about problem-solving knowledge that describes the relation between concepts and objects. So basically, structural knowledge is the knowledge that you know how to connect the declarative knowledge. Then you have procedural knowledge. It is like knowing how to do something and into rules, strategies, and then rules and strategies. So it is all are connected. As you see, a pattern is forming. So all the different types of knowledge are connected to each other. Then you have meta knowledge, which defines the other types of knowledge. And then you have heuristic knowledge that represents some expert knowledge of field. This is like an SME, subject matter expert, someone who is expertise in a certain domain or a certain area, who gives, who helps others to do problem solving. So these are like SMEs, so heuristic knowledge. So all the different 5 types of knowledge we have. So all these things are important to know what a knowledge-based agent should have or what we are going with this.
Right.
So moving on. Yes, this is very important. This is a cycle representation of the knowledge-based agent. So how the knowledge representation happens in AI. first you have the perception. It is like receiving data or information from the environment, and then find out what is the source. So what you do when you receive something from the environment, either you check what are the noise or what it is, or you check what has been damaged. So say for example, suppose we hit our hand somewhere, we immediately feel the pain. So that means that your body has reacted to that. So that's perception. Then after perception, what happens? Learning comes. Now learning is captured data by the perception component. So the goal here is to build something, build a computer that can be taught instead of programming. So what I mean here, so when the perception component acts, so when we hit our hand somewhere, then learning happens. Suppose and we try to deduce what has happened, where do we hit, what to do. So all these things, all these questions come to our mind. So the same way. Now, in order to learn, so all the learning happens because of self-improvement. So we'll be aware next time. So be careful how to move our hand in spaces, in summer, so that we don't hit again. So this is how it happens. We self-improve. We keep on improving, we learn and then improve upon it. Then in order to learn new things, the system requires knowledge acquisition. We have inference, we have acquisition of heuristic, we do faster searches. So all these things in a computer terms all happens, but we humans, what we do, we normally when we learn something, we become very cautious. So this order. Then after learning, what happens is the main thing, which is the knowledge representation. Now here, this is the base. So which shows the human-like intelligence in the machines. So knowledge representation is all about understanding intelligence, as Amrita earlier in the slide said, how the two are connected. Now, instead of trying to understand or build brains from the bottom up, what we do, the goal here is to build intelligent behavior from the top down approach, like focus on what the agent needs to know in order to behave intelligently. So, and then comes the planning and execution. Now, these two components we'll discuss separately, like the planning and execution. Planning first comes. Here, planning gives the initial state, finding their preconditions and effects, the sequence of actions that need to achieve that needs to be taken to achieve a certain state. And then comes the execution. Once you have planned, then you execute the plan. So then last is the execution. So this is the entire cycle of knowledge representation, which is important for a knowledge-based agent. Now moving on. Now, knowledge-based agent requirements, so there are a few requirements in order to have a good knowledge representation system. First is the representational accuracy. It should represent all kinds of required knowledge as accurately as possible. Then we have inferential adequacy. It should be able to manipulate the representational structures to produce new knowledge. That is, it should be able to infer from the knowledge that it has gained.
Yeah.
It's like the inference. Then we have inferential efficiency. So this is able to direct the knowledge, inferential knowledge mechanism into the most productive direction. Like we cannot infer anything from the data. So what we infer, it should give us some direction as to the actions that we might take based on what we conclude from the data. That's what data science is all about. So we have say huge amount of information, but what to do with them? So it's like meaningful extraction of the information so that we be in a certain direction. Like suppose we apply it in a business strategy, improve some product, we take feedbacks and then we improve the product, we improve the process. So this is some direction needs to be there, whatever we infer, whatever knowledge is in, of the application. Then we have acquisitional efficiency, the ability to acquire new knowledge easily without using automatic. It's like automation. It's like a self loop.
Yeah.
It's like you acquire, you update your knowledge base. You again so this is like a feedback loop. It keeps on updating. So it's still automated, and then you acquire new knowledge.
Yeah.
Moving on. Yeah. Now there are a few approaches to knowledge representation in AI. First is a simple relational knowledge. This is like storing facts in a tables. You can easily relate this simply relational knowledge to the RDBMS, so relational database management system, where you have tables, you have columns, you have rows, all these things are there. So that table in itself might not give anything. We have to take some action. We have to do some operations in the table. You have to infer from that. So the table is like a repository. You have all the information there. All you have to do is take the certain operations to deduce from the table. So that's simply relational knowledge. Next, we have inheritable knowledge. It's like hierarchy of classes. Think of this. We have the famous OOPS concept. Now from there we have one pillar called inheritance. It's like a parent class and child class. So child class is inheriting from the parent class. So this is the inheritable. How to inherit from a mother class. So it's all the informations are stored in this, in a hierarchy of classes. And the reason being, you cannot have everything in one place. There has to be something connected to each other. It's called instance relation. So it's a relation between an instance and a class.
Right.
So we have instance relation, and then we have these nodes, and then it's all about build a child class, and then you tell him to inherit from the parent class. It's easy to represent, easy to execute, rather than keeping everything in one place. Then you have inferential knowledge. Inferential knowledge about knowledge in a formal logic. So it's used to derive more facts. So it's like you infer from the data. That is what inferential knowledge is.
Okay.
Yeah. Moving on. Yes. Now, techniques of knowledge representation in AI. So there are 4 techniques. One is the logical representation. This is a language of some definite rules. It's all about logic. So there should not be any ambiguity. There should not be any duplication. It's all about setting definite rules to deal with proposition and no ambiguity in representation. So it's like forming definite logics and rules for to represent that knowledge. That's logical representation. Then is the semantic. Semantic is the alternate of the predicate knowledge of predicate logic of knowledge representation. So it's all about graphs. You can consider. You can think of semantic networks as graph structures. You know graphs. You have nodes. You have edges, and all. So that's how it is. So that's semantic. Then frame is a record-like structure that consists of collection of attributes and values to describe any entity in the world. Now, these are AI data structures you can take that divide knowledge into substructures. So it's all about representing the knowledge in definite frames, and then you break those frames in subframes, and you represent that knowledge. So it is easier to implement, easier to understand. Then you have production. Now, production, that's the agent checks for condition. If the condition exists, then production rule fires and corresponding action is carried. So this, in simple terms, means you acquire all this knowledge. You form all the representation. You form all the things. What you do, then you tell the agent to do something. What the agent will do? Now the agent will check if there is any condition exists. If there is any logic, we say like if this is true, then you do this. The agent will check that. Once it finds that the relationship, once it sees that the statement is true, then some action is gathered. This is what we do. We form all the logic, we form all the knowledge, then we take some certain actions to move forward.
True.
So this is the full techniques which are used in knowledge representation.
Yeah.
Now, this is a typical architecture of a knowledge-based system. It has an interface that is enable users to query knowledge base. It has an inference engine, which means that you infer from it. Say, for example, it interacts with the knowledge base to generate insights to support decision. That's what we do in inference. Then we have knowledge base. We have expert knowledge encoded as rules. So this is the knowledge base where all the things are kept stored in it.
Right.
So, and then we keep on updating based on certain feedback loops, certain. So this is a simple architecture of a knowledge base system. Now moving on. Yes. Now this diagram, as I said earlier also, like this is a kind of a diagram like the architecture of a common knowledge base system. This is an example. You can take it as an example. So this diagram represents the entire architecture, system architecture of the knowledge base agent. The knowledge base agent takes input from the environment by perceiving the environment as you say perception. The input is taken in the inference engine and which also communicate to the knowledge base to decide what knowledge stored in KB, the knowledge base. Now, learning element regularly updates the knowledge base by learning new knowledge. So this is what it is. So this is the entire cycle, which is similar to what I said, but this is just a more a granular representation or a more layman representation of the knowledge base. Another example you can say to how to represent the knowledge base system architecture. Then after the inference engine produce some output, which is the inference we draw from the statistic, from the data, insights and everything to do. And then that inference also help us to update the knowledge base. So it's like
if it works, then we again go ahead and update.
Yeah, that's right. Yeah. It's like an update happens and all that.
Yeah, this is important actually. This update really needs to be embedded in the overall AI architecture, according to me. And
Exactly.
I think there, as you have kind of described here, various like knowledge level, okay. And
Yes.
I think what you were trying to say, and I think I can just also like want to relate here actually, that
Yes.
we have different knowledge base agents and you can actually describe them at different levels. So like this knowledge level, I think I can understand very easily, like it is like some kind of specification, right? You are telling like from a
Yes.
taxi driver, you start from, let's say, Indranagar in Bangalore, and then you have to go to Koramangala, right? So this is like
Yes.
a knowledge, like what you need to do and everything. Okay.
Correct.
So this is like a way to A to B. Like this is the knowledge. This is the knowledge level. But would you like to explain me like what this logical level means? Like knowledge level is easy. I understand this very easily.
Yes.
But what is this logical level?
So logical level is at this level, what we do, we understand how the knowledge representation or knowledge is stored. So it's like sentences are encoded to define logics. So it is like so you have like a paragraph. Now you cannot understand the entire paragraph. What you do, you break down the paragraph into logical statements. Like if you can think of this as pointers. You point, you have a big paragraph, then you point. And then at logical level, we expect the automated taxi agent to reach to a destination B. Now, what do? When you talk to someone, you don't you don't describe everything. What you do, you give pointers to him. So see, I need to go here. This is what it is. This is the landmark. This is it. So what a taxi driver will understand, he'll form some logical statement inside his mind, like he will connect the dots. He'll say, okay, you have destination this. In the destination, there is this landmark. And then
Right.
in that landmark, somewhere in that landmark is your destination, and I should reach you to that landmark or reach you to the nearest possible destination so that you go from
Right.
there. That's what so these are like forming logical statements. So you break
Okay.
down whatever you are saying, he will break down that into logical forms, and then he will try to execute that accordingly, and then the taxi driver will take you to that destination.
Makes sense.
So that's the logical level. Yes. Now you have the implementation level. Now this is the physical representation of logic and knowledge. So what you saw in the first 2 points, you're just implementing those things. This is how you represent. Now implementation level, agent perform actions as per logical and knowledge level, and an automated action actually implement his knowledge and logic and it reaches destination. So this is how. So logical level, think of this, he broke down the entire whatever you said into logical statements, and then he implements that, he actually takes you to that destination or nearest to that, so that you go from there in your target destination. So this is what the full 3 levels of knowledge is.
Yeah, this is actually very interesting.
Yes.
So I would say that when we are taking these different approaches, we should also look into the what kind of approaches. So according to you, like how would you say like what is declarative? Procedural is
Yeah.
something I understand because I have programmed some procedural code, but what is this declarative? What do we mean by
Yeah,
this?
declarative, we create a knowledge base agent by initializing with an empty knowledge base and telling the agent all sentences with which you want to start with. It's like, say, for example, you start something, so you have an so this declarative approach is like this. So let me
Sure.
explain in this simple terms. So you create an agent. Okay. Now, when you create the agent, you don't give everything to it as of to start with. What you do, you create an empty database, and you tell the agent all the sentences with which you want to start with. So you give certain inputs. It's like initializing. If you know optimization, okay. Now you can start with initializing with 0, or you can start with initializing some random numbers. Think of this like this: you give an agent something to start with. Okay, you don't tell the agent to start from the scratch. You give the agent to do it. So say for example, you create an agent to roam around the park. Now, so you create the agent. Initially, it is the knowledge is empty. You tell the agent that in the park you go to that ice cream parlor, you buy one ice cream. You go to that dog and you play with it. You go
Right.
to that Ferris wheel, you spin on it. Like this, you give some initial conditions to start the agent with, so that the agent will start with those, and then he keeps on updating based on his experience in the park. So that's what it is. That's declarative approach. You give the agent something to start with, then the agent will keep on updating based on his experience on the park or wherever the agent is program to go. So then he keeps on updating his knowledge base. It can happen that will completely override everything that you said you start with, or it can happen that he keeps on appending to what you start with, initial conditions. So it's up to the agent and up to how the agent is built like that. So that's the clarity approach.
Yeah. I think procedural, as I understand, and I have coded a little bit in procedural languages, like you primarily encode the whole behavior as a programmatical code, and basically you would kind of design this, because I have also tried to design the conventional AI, like where I had to design a robot motion and everything. And yeah, we had to like factor in almost anything and everything very much by ourselves, because we understood what this 2D world of robot is. And I think that is the procedural level implementation or procedural approach of implementing any kind of knowledge base, that as a coding itself, within the code itself, we are kind of including all this. But this then makes coding very complex actually, because then you have to think about everything. Yeah, that's interesting. Hey, so yeah, so thanks for explaining. But we should also be looking into what kind of operations are performed by knowledge base agents. So Tamal, would you like to expand on this idea?
Yeah, that's right. So this is very important to understand. Like these are some of the operations that are performed by knowledge base agent. I mean, we are expecting at least to show some intelligent behavior when a knowledge base agent performs these three actions, like tell, ask, perform. Now, tell means you tell, the operation tells the knowledge base what it discerns from the environment. So this is similar to the perception. So it tells the knowledge base what it is understanding from the environment, what are the inputs it is receiving from the environment. Then it asks, this asks the knowledge base what action it should perform. So based on the input, what action the knowledge base agent should perform, and then perform. So actually do the action. So that perform means actually do the selected action, whatever is given. So these are the three main operations which a knowledge base agent will perform if it shows an intelligent behavior. I mean, we're expecting the knowledge base agent to show these operations.
Right.
So moving on. Yes. Now, to your right hand side, you see a very basic function of a knowledge base agent. What it takes is it takes some input, makes some query, and then do some action. Now, the knowledge base receives the percept and the input, responds with an action. So that's tell. Then the knowledge base adds the knowledge base, and it comes with some real world experience. And it also features a counter that starts to indicate how long the operation will take. So it's basically, the counter is basically for the knowledge, I mean, for us to understand also for the knowledge base agent, how long the operation is being performed. Now, to begin with, it tells what it sees. That's the input. Second, the knowledge base takes some action, what action it should take. So that's internal. And then finally, the third agent performs the info the knowledge, the action that was chosen. So tell, ask, perform. So these are the three things that you see in the action. I mean, in the function. So basically, this is how the function is. This is by no means is the exhaustive function. This is just a small example of what the knowledge base agent will have if it had to execute the three main functions that we just discussed.
Right. So, and this is I think very important. And as I'm looking in this function, one could even it looks like a pseudocode. One could think about generalizing this idea into a proper programming language where we have your input and we have our interim output, and then and then we take like the final outcome. Now, this sentence does not mean exactly English sentence here. It is fundamentally like an outcome that is coming, and this is the final action that we are taking, and then it kind of goes in iterative loop. And I could see that it will keep on doing. And this is something that definitely needs more formalization.
Correct.
I guess
one can, yeah, that's right. Yes, you're right. I mean, one can think of this function very similar to the reinforcement learning agent. I mean, you can do some reward punishment thing also here, and you can just form and you can analyze, as Amit said, to make it a more general function where everything is included. So you can think of in that direction also. So reinforcement learning agent with all these things can also do the similar thing if you configure them.
Interesting.
Yep. Now, basically, the make perceive sentence is what the input is. The construct sentence indicating the agent perceive some specified perceive a specific time. So that the first make perceive sentence is so basically the input. then it asks some action query. The command provider says that asks what action that needs to be taken. And then actually the selected action was carried out in the end by the make actions.
Yeah, definitely. It is again like that we kind of already explained. So you get your input and then you have like a interim outcome, what action to be performed, and then the sentence which states that this action was selected and this was performed out. And later maybe iteratively it can be again put back in the knowledge base. Yeah, this is interesting, and this is something that we need to dig in for the future in our research as well. All right.
Yes, that's right.
This is interesting. Now, in terms of storage, we do have different options on how we will be storing the data. And the traditional well-known way of storing unstructured data is key value pairs. As you might know, MongoDB is definitely the leader here, but we have like Azure Cosmos DB, ArangoDB. Okay, here you have the ways to store like unstructured data in a key value pair, very similar to like what we do in Python dictionary. But one which I am particularly excited is Neo4j and Tiger Graph. Okay, like particularly these graph-based data sets are something that are really useful. And as I was kind of explaining at one point that any kind of graph can be imagined based on this, and you can start imagining, let's say Google is in business of search. Let's say it uses AI, and let's say it uses databases as well. So all of these can be explained very well in a connected scenario through graph databases. Now, there are other options of GraphDB, MarkLogic, plus AWS and Stardog are also available. Okay. Of course, you can always have a simple document as well, but I personally feel it's far better to go in this direction where we can be looking to store the data and all the relationships of this data into like some kind of a graph data set. Okay. So this is something that I really feel that would be the future, and where we will be constructing and storing and building our knowledge base. Okay. And if we like to kind of, I would like to kind of now think about a conclusion and would like to say, what would be the advantages of knowledge graph? And as you can imagine that, first of all, of course, it will be far better in matter of storage of all these connectivities. Okay. And plus graphs are important to visualize AI and machine learning algorithms. This is something that we have done it for neural networks already. And like direct acyclic one-way graphs like DAGs are used in Git scheduling algorithms, and they form the core of many neural networks or tensor-based models in many modern applications. Now, its representation of dependencies enable its use in Airflow task processing apps as well. And here we can also see different examples of deep learning, recommendation engine, predictive analysis, NLP text mining. We do use graph or knowledge graphs in a lot of ways, and we would like to infuse such knowledge graphs very well in the traditional AI or kind of the development of artificial general intelligence. So I think, Tamal, this leaves us to a very interesting conclusion, and we would definitely like to kind of continue the research in this direction where we can include the knowledge or the all the knowledge base in our current day artificial intelligence as well. And hopefully we are able to do it soon, as because AI and especially pattern recognition and neural networks, we are seeing progress every other day. So by infusing some kind of knowledge graph or knowledge base, we will be able to give AI a level of power that is just not there right now with any of the pattern recognition systems. And they do end up requiring large amount of data to kind of learn any pattern and come to any inference. And this is something that we are trying to ensure that that does not has to happen. And plus, using knowledge base, we will be able to continue lifelong learning with a single model or a variation of the same model, and it will keep itself updating. Okay.
Correct. That's right.
All right. And I think this is where we can leave it off and we can conclude. And thanks all of you. Thanks, Tamal. And this is all for this video. Next one, we will be looking into neuromorphic computing, how it can help in AGI, one of my favorite topics. Although we do have a case study of chess, and we will be including the links in our video description. Please have a look in this case study. We realize that it will become too big if we try to take these case studies in the video, but we have put their links in the YouTube description. Please find them. Thanks for your continued support, and we'll see you really, really soon in the next video. And till then, bye-bye. Take care.
Bye.
Bye,
Take care.
guys.
Thanks, everyone.
Bye.
Bye, guys.